Welcome to the seventh module. This is the final module discussing the concept of arrays. Here I will be talking about arrays that hold characters as their values. For the arrays themselves, I shall explain what they are and how to initialize and declare them. I shall also discuss how to process these arrays. Since these arrays hold characters, we can also do some operations which are exclusive to them, such as character case conversion and character testing. This will also be explained and expanded on in this module. Arrays of characters are known as strings. A string is a general term for any array of characters saved in a sequential space of memory. When initializing or entering an array of characters, it will always finish with a null terminator. The null character is used as a single character to signify the end of an array of characters. Here are some examples on initializing an array with no size declarations. The first initializes the array by assigning it the string literal John. By doing this, the null terminator is automatically placed at the end. The other initialization is done by implicit declaration. Here the null character needs to be placed manually. Next is another example, this time initializing an array of characters with a size declarator. The array is declared to be an array of 9 characters, but the name Jane Doe is only 8 characters. So we've created an array of size 9 because it needs an extra element for the null character. Without it, at the moment of printing, the compiler will not know where the string ends. When doing implicit sizing, you must add the null terminator. If the array has a size declarator, the extra elements will be given the null character. When declaring an array of 2 dimensions, the number of different arrays that can be written will be decided by the size of the first pair of brackets, the rows. The second pair of brackets will determine the amount of characters in each array. For example, the following statement can hold 5 arrays of 9 characters each, because the 10th element we reserve is for the null terminator. Below, we have 2 different methods to declare the array, similar to the previous slide. We declare it in the 2-dimensional array the names Jacob, Robert, Henry, Emma, and Jonathan. Both methods give the same results as seen on the following table. By using the first index of the array, we can have access to the names stored in it, and then use the second index to manage the characters that make up that name. A C-string is a string of characters that is finalized with a null terminator. A string literal, also known as a string constant, is any string that is contained within quotation marks, and they are saved in separate area of memory and finalized with a null terminator. Before, we learned that if we try to print an array, the address will be printed and not the contents. This rule does not apply with C-strings, because when the stream insertion operator receives the address of an array of characters, it assumes that it contains a C-string and it sends it to cout. Here we have a simple program that prints some of the names from the previous name array. When printing from a double array of characters, you write the name of the array and only one set of brackets. The subscript inside the brackets will represent the row of the 2-dimensional array that is going to be printed. So the statement names with subscript 1 will print Robert, and the statement names with subscript 3 will print Emma. Take note that the C string will print till it reaches the null terminator. If a null terminator is not found, it will continue to print garbage. In this slide, we have a program that asks the user to enter a name and then prints it on the console. After doing this twice, the program terminates. When inputting a string with the following statement, cin person, you can receive a string, but it will not accept spaces. If the string entered contains a space, it will only save tilde space, and the rest of the string entered will be accepted the next time another cin is encountered. With the previous statement, cin does not know how many characters are in the array person, and it will accept any given string, writing over its boundaries. The getLine function fixes these problems by accepting a string until the enter key is pressed, or the end of the array is reached, and it automatically adds a null terminator. The following statement is an example of how to use getLine. You call cin.getLine with the name and size of the array as parameters. getLine then takes care of receiving the string similarly to a normal cin. If the entered string is longer, it then receives up to the size of the array, adding the null character at the end, and discards the rest. Sometimes in a program, you will want to test the value of a character entered, and by adding the CC-type header file, you can add functions that test one character at a time. For example, in this snippet of code, we have a char-type variable called digit that stores the character 3. Not the value of 3, but the character representation of it. Then we use a function included in CC-type isDigit to verify if the character sent as a parameter is a representation of a number. The program then prints the result of the validation on the console. The CC-type library includes many functions for character testing, as can be seen on this table. IsAlpha verifies if the character is a letter of the alphabet. IsAlnum verifies if the character is a letter of the alphabet or a digit. IsDigit, as we saw previously, verifies if it is a digit from 0 to 9. IsLower checks if it is a lowercase letter. IsPrint checks if it is a printable character. This includes whitespace. IsPunc verifies if it is a printable character other than a digit, letter, or space, a punctuation. IsUpper checks if it is an uppercase letter. And finally, IsSpace checks if it is a whitespace character, such as a space, a tab, or a new line. The CC-type library also offers functions that can convert characters to their uppercase or lowercase equivalent. For that, you use the functions toUpper and toLower to get these results. Here we have a program that shows the process of converting a character from lowercase to uppercase using the function toUpper. First, it prints the letter before the conversion. Then it prints the result of the function toUpper. It is a number because this function returns the numerical representation of that character in the ASCII character code. C++ uses that code to represent characters. Finally, it prints the character now in uppercase. The program loops until the user decides to quit the application by typing N on the keyboard. The user answer is taken and converted to lowercase before being validated.